Good evening, everybody. Can you hear me? Okay. You can now? Yeah. Good evening, everybody. I'd like to welcome you to the Department of Atmospheric Oceanic Sciences 9th Annual Robock Lecture. We have, by the generous gift of the Len Robock family, we've been able to sponsor this lecture, this public lecture, once a year for almost the last decade, and we will continue to do it in the future. The idea that the Robock family had was to have our department be able to find a person who would come and talk about an issue in the scientific realm that was an issue of public concern, but was going to be open to a wide audience. And I think tonight we've really struck gold. We've done well in this thing before, but we've really hit the jackpot tonight with inviting Marshall Shepard from the University of Georgia to be our speaker tonight. I just want to tell you a little bit about Marshall. He got interested in the weather because he got stung by a bee. That's a true story. I won't spend his time telling you why, but you might ask him afterwards. I'm trying to set you up for questions. And Marshall got his 3 degrees at the Florida State University, both his BS, or all his BS, his master's degree, and his PhD. And Marshall was the first African-American ever to graduate with a degree in meteorology at Florida State University, which has had a program for a very, very long time. So that's a distinction of note. He is now the director of the Geography and Atmospheric Science program at the University of Georgia, and he's been there since mid-last decade, I think, right, 2005. He's had a long, distinguished career at NASA, where he worked on the Tropical Rainfall Measuring Mission and the Global Precipitation Measurement Mission. And he's also worked on urban meteorology and urban climate issues. So he's got over 100 publications. He's been a scientist of great renown and great contribution. In fact, he won the Presidential Early Career Award for Science and Engineering in 2004 and was awarded that by President Bush at the time. He moved to the University of Georgia, as I said, in the middle part of the last decade. He's a contributor to Forbes magazine. He's a semi-regular on the news all over the various cable channels as an expert on weather and climate. And since 2013, he's been the host of the Weather Channel's Weather Geeks program, which is the only Sunday talk show in the nation that deals exclusively with science issues. And boy, is that timely right now. And he'll maybe tell us a little bit about that in the question and answer. But it's a great pleasure to have with us tonight Professor Marshall Shepard, and he's going to talk to us about zombies, cola, and sports, and I can't wait. I had the opportunity of choosing one of several options, and this is the one that I chose. Everyone seemed to agree. I don't know what's coming, but I know it's going to be good. Marshall, thank you very much.
Can you hear me in the mic okay? Okay, yeah, I don't know what's coming either. I never know when I do the talk. It's really an honor to be here in Madison, a little cooler than Atlanta, where I come from right now, but actually happy to be here. This is really an honor because I'm a meteorology person. I did all of my degrees at Florida State, but one of the most storied atmospheric sciences programs in the world is here at the University of Wisconsin. So for those of you in the public that are here tonight, be proud of the fact that you have a very pioneering institution here on your campus in our field who has really led the way in advancing our field. The Len Robock Lecture. When I got this invite, I thought that I was going to be speaking to a group of colleagues only in the Atmospheric Sciences department. I didn't realize it was going to be a large public lecture, but that's okay because I like talking to whomever, especially about weather and climate. I suspect it will be obvious that I'm passionate about this topic as we move forward. You probably are wondering how in the world I'm going to tie all of those things together, but believe it or not, I sort of do. And in fact, at some point, being the professor that I am, I may test you from time to time to see if did you get the cola? So let's just move forward. And by the way, notice very serious, a very humorous cartoon here noting the removal of Florida there in this cartoon, but they are facing a very significant and serious threat right now that I will talk about here shortly as well. There's my coordinates, some of the things about me. I have an endowed professorship from the Georgia Athletic Association. They're distinguished endowed professorship, so I don't do research on athletics or injuries to legs or pulled muscles or anything like that. But when people see that in my title, they'll often ask me what that means. It's just an endowed professorship in the same way that IBM might have an endowed professor of computer science. So we have a very unique, interesting arrangement in that the Athletic Association at the University of Georgia actually gives gives about $14 million back over to the university for endowed professorships. So it's a really nice thing that hopefully other universities will adopt. As you said, I'm the director of the Atmospheric Sciences program at UGA, past president of the American Meteorological Society. So if you watch your evening news and you see AMS by the name of the TV forecaster, that's what the American Meteorological Society is, although most people that are members of the American Meteorological Society are not TV broadcasters. Although when I tell people that I am a meteorologist, they will immediately ask what channel I'm on. And so most meteorologists are not on any channel. I do host the show Weather Geeks, comes on every Sunday at noon, probably 11 your time. It has been preempted the last couple of weeks because of the sort of weather Harvey, and it certainly will be this week as well because of Hurricane Irma. If you want to follow me at Twitter, if those of you on Twitter, I'm at Dr. Shepard 2013, feel free. I'm quite active there. So I looked at the charge for this lecture when they sent the invitation, and it says the department bring in an expert to give a public lecture on an issue related to the public interest: climate change, tornadoes, hurricanes, hydrothermal vents. I won't be talking about hydrothermal vents tonight, but I think have covered most of the other things up there in some fashion, as you'll see. I actually am a practicing scientist. I am a researcher. I did, I guess, your public radio today, and they introduced me as Marshall Shepard, meteorologist with the Weather Channel. And I immediately corrected her and said, I'm a professor at the University of Georgia who happens to host a show on the Weather Channel, because I very much identify with being a scientist. And I have all of the sort of things on my resume that most scientists and professors at a university have. But more recently, I've been more interested in this notion of how we communicate extreme weather and climate. It's a challenge of our time and on many scales. And so that really is the notion of what we want to talk about tonight. But first, let me give you an Irma update. And unfortunately, I didn't even get a chance to update this particular graphic. But I am very concerned, and I am not the type that is overly dramatic. In fact, people in the room that know me know that I'm not. I'm very measured. But I fear that we are setting up for a worst case scenario in Florida right now. With the latest model track of this storm, and I'm going to see if I can outline it for you, the Irma is coming right in here and going right up the peninsula, according to our latest models. That puts the most populated areas of South Florida in the right front side of the storm, which is typically the strongest winds, the worst surge. So we have a highly populated area, a major, that's what the M stands for, hurricane, and populated area in the most dire area of landfalling storm. We'll even be dealing with the storm in Georgia early next week as well, likely still as a hurricane. So I wanted to give you that update. These are some of the really impressive pictures and images that we've been seeing from various satellites. This is from the GPM satellite, which is a satellite that NASA launched a couple of years ago. I served as a deputy project scientist for that particular mission when I was at NASA. Some other views of the storm. So I wanted to start, before I really get into the talk, with an update on Irma. Now, kind of transitioning to the theme of the talk, communicating Irma raises questions. And I want you to think about these questions as I talk about them, because one of the things that many of us find as a challenge now in communicating to the public on a risk like this is not the meteorology. We've kind of figured that out to some degree. There's still things we need to do. But communicating and the perception issues associated with the message that we put out. So for example, we know that people are currently evacuating in Florida. But if we tell people to evacuate and the storm goes somewhere differently than where they expected near their home, or they get back and their home was fine, are they going to say it was a failed forecast? We deal with that quite a bit in our field. Do people understand the cone of uncertainty? How many of you, by show of hands, sort of feel like you understand that cone that you see on the Weather Channel or on the evening news? I'm not going to test anybody and see if you actually get it, but we find that there's a lot of misunderstanding of what that cone means. There are people that feel that if the storm doesn't go down the center of that cone, that it was an inaccurate forecast, when that cone is actually representing uncertainty based on future assessment of past assessment of storm tracks. How do we overcome hurricane amnesia, stubborn tendencies, or past cry wolf? Does everyone know what I mean by those three things? Until Harvey, we hadn't had a major hurricane make landfall in the U.S. for literally 10, 12 years. Twitter didn't exist the last time there was a major storm make landfall in the US prior to Harvey. And so the fear is that people forgot how to prepare for them. There are people that lived in coastal communities that never even experienced that type of storm. So they may not even understand how to deal with them or prepare for them. Stubborn tendencies. Oh, I've seen Irmas before, I've lived through. In this case, maybe not. Harvey, you haven't seen that kind of storm before. And so the challenge is getting people to understand that sort of the analogs in their own historical context may not be representative of the storms they're now facing. And then the past cry wolf. This is something that I was very much fearful of with Irma. Last year, everyone remember Hurricane Matthew. Matthew was barreling towards Florida and then just paralleled the coast. And you had quite a few people in South Florida evacuate. I bet a lot of people remember that. And they were like, oh, this is just another Matthew situation. I'm not going anywhere. But yet, if this bears out, and I think colleagues in the room would agree with me, if this path bears out that we see for Irma, this is almost the worst case scenario for South Florida. It's the kind of scenarios we've warned about for years in our classes. So let's take a look at Harvey, another anomaly event, and I'm going to set forth some data from NASA, from the satellite system, one of the satellite systems that I work with, and you're going to see the sort of evolution of Hurricane Harvey, which came into Rockport, Texas, Category 4 storm, very much destroyed that landfalling location, but then sat there for days. 50 plus inches of rainfall in parts of Houston, Texas. And so now you're seeing some of the unique technology that some of the NASA satellites have in place to look into the storm. But even Harvey raises challenges and questions. One of the biggest things that I was worried about with Harvey was the phase A, phase B nature of the threat. We knew that this was going to be a Category 4 storm that made landfall. And I think most people are accustomed to the dangers associated with that. But meteorologists also understood that this was going to be a flood threat that would produce 3, 4, maybe even 5 feet of rain. We knew that, yet I still heard public officials on the news say, we didn't think it was going to be that bad. I didn't know where it was going. And I think that was because we saw a couple of things happen. Storm made landfall, Category 4, and then you started hearing language like what on the news? Weakened, downgraded. And that creates a perception challenge. Because if you don't understand that perhaps an equal threat to the landfalling storm is 4 or 5 days of rainfall that will provide 50 inches of rain, you may underestimate that threat. So that's an example of a challenging communications or messaging part of the story. Do people have a heightened sense of risk for rain as they do with tornadoes or hurricanes? If there were a tornado warning or, in the next hour, I guarantee you we would be asked to clear the room. Our threat level or our risk perception would be very high. If it started raining heavily outside and for a long period of time, it's a different type of threat, but I don't think it sort of evokes the same level of risk. So I had people telling me, oh yeah, we get floods all the time. It rains all of the time here in Houston. So there was a perception about floods and rainfall, and that's one of the biggest challenges we have. Does familiarity with rain and floods reduce risk perception? Sort of same thing that I was talking about here. And the question that has been floating around as I play this little animation, this is the 7 days of rainfall leading up to Harvey. So if you look closely, you'll see Harvey there spinning around. This is again from the one of the NASA satellite products that I work with called iMerge. Does flooding from Houston and Harvey indicate climate change? We see this with severe and extreme events all the time. And I'll deal with that question a little bit later because it's an ill-posed question to suggest, was Harvey caused by climate change or is Irma caused by climate change? So keep these backdrop questions in your mind as we go on our journey to try to figure out what the hell Shepard's talking about with zombie colas and sports. All right. So my goals tonight are threefold. I want to highlight several challenges with communicating weather and climate change. Basic goal. I want to challenge some of your own perceptions and biases. So get ready. And I want to offer some solutions where possible. I don't have all the answers at all. And we have to understand in doing this, there are a couple of caveats. This is the backdrop that my field and community is working against. Everybody's an expert in weather and climate. I've got 3 degrees in meteorology. You got one of the best atmospheric sciences programs in the world. Yet some guy on Twitter thinks he knows as much as John Martin about this stuff. You know, that guy is a rodent. But I will seriously have someone say, well, what do you think about the groundhog forecast this year? And then in the next breath say, but you know that climate change stuff's not real. Farmer's Almanac. Right down the road, the CEO, United Airlines in Chicago, cited the Farmer's Almanac in his decisions about where he was going to move planes last winter. If you go and look at the studies on the Farmer's Almanac, 30% accuracy, 37%. The climatological forecast. He's a TV meteorologist, and because people feel like they know him and they see him or her every night, there's the expert. I deal with this with my own mom, bless her heart. I told her one day, Mom, you know, we're from Georgia. I said, Mom, there's going to be 3 inches of snow in part of Georgia you live in. That's not what Glenn Burns said, who's the TV meteorologist in Atlanta. Hey, Mom, I too am a meteorologist with a bit more schooling, actually, than Glenn Burns. But people feel like they know and trust their TV meteorologist, which is fine. There's some good ones out there. Yeah, my knee's aching. It must be going to rain. There's actually some truth to that, by the way. Now, we have a couple of barometers in our bodies, things that can sense changes in atmospheric pressure, joints being one of them. Your ear pops when you go up on a mountain or airplane. That's just a pressure response. And then I put this up. This is the set of my show on the Weather Channel, Weather Geeks, and this fellow here is Dr. John Knox. He's one of my colleagues at the University of Georgia, but he actually got his PhD here at the University of Wisconsin. His co-author, Steve Ackerman's in the room. They have one of the best introductory textbooks in our field. So this is one of the things that we're up against as we're communicating and messaging. And then there's Twitter guy. This poor soul has spent all this time sort of elucidating his expertise, and then some guy on Twitter says you're wrong. That is a reality that we deal with on a day-to-day basis. And then this is something I pulled off Twitter just yesterday. There's actually a journalist for BuzzFeed that was keeping track of all of the misinformation and fake news about Hurricane Irma. This is the world we're in, where a news organization has to assign a journalist to do that. But that's the backdrop that we're up against as we communicate. So let's now walk through 6 challenges of communicating weather and climate change. And the first one is overcoming perceptions in psychology. Overcoming perceptions in psychology. Let's start here. Most people think that the most deadly or most fatal weather on a year-to-year basis in the U.S. is probably tornadoes, hurricanes, or floods. It's heat, boring heat, but deadly heat. Give an analogy to this. In Georgia, in the summertime in August, it can be close to 100 degrees with a lot of humidity. A Little League football team out there practicing in August. If there's a storm that comes along and it has lightning in it, they'll clear the field. Yet they'll let them practice in full pads with 100 degrees and 105 heat index. Which is more deadly? Well, you can argue that. But the point is, the perception is that these things are more deadly, yet heat or extreme events related to temperature, according to National Weather Service statistics on the 30-year average, are the most deadly weather. But I don't think most people, if I had asked you, if I said, what is the most deadly weather each year in the U.S., I suspect the majority of the room would not have said temperature. That's just my suspicion. This is a picture of Atlanta after all 2 inches of snow that we received during snowpocalypse or snowmageddon or whatever you want to call it. This event was primarily caused by a perception or misunderstanding issue with these 3 words. Because as that event was unfolding, oh, did we just go to sleep or? As that event was unfolding, we were in a winter weather watch or winter storm watch. And at some point we transitioned to a winter weather advisory. And many of our stakeholders and decision makers understood that, or thought that that was a downgrade, when in fact it wasn't. And so resources weren't mobilized, certain decisions weren't made. I often have people tell me in parts of the country that don't get tornadoes all the time, they get confused by something that to many of us is trivial. They think tornado watch means we're watching the tornado and that it's happening, and a warning is that it may happen. But we all know that tornado warning is actually the more severe of the 2 situations. So just simple perception and understanding of words and terminology can end up creating this. "40% chance of rain." How many knows with confidence, absolute confidence, what that means? I've already thrown a curveball at you. What does it mean? That's generally how it's interpreted, but there's actually if you go to the National Weather Service, Peachtree City, which is the National Weather Service Atlanta, the probability that a pop is related to the confidence in the forecaster's understanding of that over a given area. But it's getting more complicated because we do these grid forecasts now too, and it is starting to change. But let me give you an example of something that every meteorologist in this room has heard, every one of them. Hey, it must be nice to work in a field where you can be wrong 50% of the time and still get paid. Hear that a lot. Meteorologists, who's heard that? By show of hands. All right, I didn't lie to you. When someone tells me that, I smile because I tend to want to speak my mind, but I'm very tactful. Because immediately when someone says that to me, I immediately understand that they don't understand something about statistics, probability, and weather. So I was tubing, going down the Chattahoochee River with my son one summer in these inflatable tubes. Starts raining. And a woman next to me, she had no idea that I was an atmospheric scientist or meteorologist. She says, "See those meteorologists, they don't know what they're talking about. It was only a 20% chance of rain today." And I'm thinking to myself, well, it wasn't 0. But the reality of that situation is people perceive if it rains when there's a low percent chance of rain, they perceive that to be a missed forecast. Another example of this notion of perception of forecast skill, you guys have started your football season. Your football kicker here at Wisconsin makes every single field goal kick. But you go to the national championship game and he misses the one that could win you the national championship. What are people going to remember? Are they going to remember that he made every single field goal kick that season or that one? That tends to happen in meteorology too, because we tend to be pretty accurate with most of our forecasts. But people remember the event that impacts them in some way. And then there's polar vortex. Every time it gets cold, there was a time a couple of years ago, every time it gets cold, it's the polar vortex. Right? My kid got a cold, it's the polar vortex. And my engine light came on, it's the polar vortex. Everything was polar vortex. Right? And so this is just an example. I even had some well-meaning scientists on national news saying things like, "Oh, it's like an Arctic hurricane. Like a polar tornado." It's none of that. So you have to be very clear and cognizant about messaging, even if you see it on TV. What are some other things that we misunderstand in terms of our perceptions? These are what I call zombie theories. Zombies. You're going to see it again, too, later. Zombie theories are those things in science that we've long explained away as scientists, yet they live on like zombies. Yeah, people in the South, at least, I don't know if it's a big thing up here, who's heard of heat lightning? Oh yeah, it's lightning caused by the heat of the day. The sky's all hot and it gives off lightning. That's not what heat lightning is. Just lightning, you can't hear the thunder, it's too far away. We see the lightning, thunders, it's too far away. Does it get cold in deserts? Yeah, it does. I already just dealt with that one. Chemtrails. Ask any National Weather Service office how many calls a week they get about chemtrails. I'm not kidding you. That's a good strategy. Or I said, well, it's getting cold outside and my breath is coming out. Boy, that's a chemtrail, right? Just physics. Polar vortex, watch versus warning. Here's a good one. It's just more of a misunderstanding. I taught a class at the University of Georgia last semester on weather risk and communication. And we read a paper. Typically when there's a severe storm or a tornado, they'll put a polygon on the map like that, trying to indicate the watch or warning area. There are studies that show that some people think that the threat is only in the middle of the polygon. Some think it's here, some think it's here. Some can't even identify what county they live in. So these are the challenges that we deal with. Weather apps are always right. This is a new one for us, but a misunderstanding that when you pull up your little weather app and it's got the smiley face emoji with the sun, Mr. Sun, hi. You know, sometimes those aren't updating in evolving or rapidly evolving weather situations. So be careful about your interpretation and use of your weather app, right? And beware of wish casting and watching the evolving forecasts. Happens a lot in the South because we don't get as much snow as you guys do. So whenever there's a snow threat, people start wish casting. And I was like, well, that's not what the forecast is saying. The models are saying we're going to get sleet. No, but it's going to snow. Here, don't you know? And by the way, lightning is not spelled with an E. That's my public service announcement for the night, because I see that all too often. All right. Another part of perception is something that my colleague Susan Jasko from, she's a communication professor at California University of Pennsylvania. This is the flooding event that happened in Baton Rouge, Louisiana in 2016, but it could very much be applied to Harvey in Texas just a few weeks ago. Susan says, I think it's very difficult for people to truly imagine what they've never known. That's a true statement. If you think about how many experiences one has in life where the people who have had that experience tell you it's going to be like X, you nod your head, you know, yeah, sure it is. But when you go through the experience, you end up thinking, wow, she told me it would be like this, but I just didn't really understand. And that's what we often see with Hurricane Irma or Harvey. I've been through a hurricane before, but Harvey and perhaps even Irma is something different than people have experienced. They don't have a contextual reference point. Yet they still make decisions based on their historical reference. That's a challenge. And there are changes in climate, and we have perceptions in psychology to overcome there too. So there's my friend the polar bear. I'm going to set this little NASA animation of sea ice in the Arctic. This is data from NASA showing changes in Arctic sea ice over the last several decades. You can see the time here. So this is the late 80s. This is both perennial and sort of short-term, long-term sea ice. And what you're going to see as we come up through current times, gradually, that's going away. It's going away to the point that there are cruise ships now offering cruises through the Arctic Ocean. You can actually take a cruise. There are ships coming through the Northeast, Northwest passages now. Because as we see, we're up to 2001 now. Are we seeing how that's gradually growing away and water is opening up? The darker color is water. We've gone through, and I'll touch on that in a second when I talk about Milankovitch cycles. So just hold that question. That's dramatic, folks. I'm not hyping this. That's just what it is. But the perception issue is people think that climate change is just about polar bears and what's going on in the Arctic. And I think they have this perception, oh, that's nice, we do care about the polar bears, but I care about my budget in my household more. But the reality is, cola. The reality is, companies like Coca-Cola, Jeff Seabright, look what he says, increased drought, more unpredictable variability, 100-year floods every 2 years. Seabright says, when we look at our essential ingredients, we see these events as threats to their bottom line. That's a Fortune 500 company that talks about that water supply, sugar beets that they use for their Minute Maid product, oranges, apples, lemonade are vulnerable to climate change. So the perception that this is about polar bears or monarch butterflies is flawed. In fact, 2012, I was testifying before the Senate. We were in the midst of a drought, 2012, 2013, and food prices are going through the roof because of that drought. And Senator O'Dell, who I don't remember exactly where he was from, said, well, Dr. Shepard, how do I convey to my constituents the connection between the drought and them in New Mexico? There's no drought in New Mexico. I said, do they eat Cheerios or cornflakes? Because they're paying more for them. So this is how we have to connect the dots to overcome some of those perception issues. Look at what's going on recently. Have you seen gas prices? Since Harvey, gas prices are up at the pump, up almost 50 cents a gallon or more. Basic economics, supply and demand. One of the primary pipelines from a major refinery region shut down. So we can remove these perceptions and then we can start to advance knowledge. Beth Gardner wrote a nice article in the New York Times a few years ago. She interviewed a psychologist at the University of Victoria, Robert Gifford. And Gifford said that there are challenges that are related to psychological and behavioral aspects of our personalities. People have a trouble imagining a future drastically different from the present. We struggle with that in our own minds. We block out complex problems that lack simple solutions. We dislike delayed benefits and so are reluctant to sacrifice today for future gains. Politicians struggle with that too, because climate solutions aren't on 2, 4, and 6 year cycles. So is there any political gain from making those types of decisions? And we find it harder to confront problems that creep up on us than emergencies that hit quickly. These are psychological perception issues that we struggle with. So perception issues. Challenge number 2, science is not a belief system. I believe that. Some might argue with me about that, but I don't believe that it's a belief system. And the reason I say that, we have to sort of look at the 6 Americas and see if you can find where you are in terms of climate change. This is a study out of George Mason and Yale, and they say that Americans break out into 6 different categories as it relates to climate change. This is called the 6 Americas study. Dismissive up to the alarmed, and some of you probably fall into one of these categories. This is the category I deal with on Twitter a lot. I kind of just dismiss them. Yeah. So, because you're not going to change they just want to argue for argument's sake. There are people that have very doubtful but reasonable counter arguments. I'll deal with them. But there are some that really just want to be dismissive. Why is this thing? Where are you on that? Just kind of think about it for yourself. Yet I often get this question, Dr. Shepard, do you believe in climate change? Believe in climate change. I said my 10-year-old believes in the tooth fairy, and he needs to get over that. He's a little too old. I just had to give him $1 the other day. Is it still $1? That's what he gets. Believe in the tooth fairy. I mean, do we believe in gravity if I jump off that building? Do I believe in gravity? Well, I don't want to jump off and see if my belief system's right or wrong. But that's what that question feels like to me when someone asks me if I believe in climate change. So we got to remove that notion of, I think there are different ways to ask the question. I want to kind of, before I leave that, I think there are questions, well, where are the uncertainties still in the climate models? Can we really attribute a singular event to climate? I mean, I think they're fair questions that someone that may be doubtful should ask, but I really believe we need to, erode that question about belief. Challenge 3, confirmation bias and the Dunning-Kruger effect. How many of you have heard of the Dunning-Kruger effect before tonight? A few of you have. All right, so these two psychology professors at Cornell, David Dunning and Justin Kruger, published a paper noting that the Dunning-Kruger effect is defined as a cognitive bias in which unskilled individuals suffer from illusory superiority, mistakenly rating their ability much higher than is accurate. In other words, people think they know more than they do. I didn't need a fancy psychological term for that. But I understand. I get it. I mean, and I put that slide up earlier about everyone really understanding in their minds meteorology and climate because they experience weather and climate. I can go, is there Walmart up here? You guys have one. I could go to Walmart right now and just sit there and have a sign up and say, hey, I'm a meteorologist / climatologist. I'll get people that come up to me with their opinions on weather, on climate change. I wonder how many nuclear engineers can go into Walmart and say, I'm a nuclear engineer, and see how many people come up to them with their opinions on nuclear engineering. Probably not as many. We work in a very unique field where people feel like they understand it. So, a question that drives me absolutely crazy. I'm sorry, I just had a flashback to just 2 days ago when someone came up to me and said, well, Dr. Shepard, the climate changes naturally. Now, how in the world did I get through 3 degrees in meteorology and not know that? Just tell me. I mean, Florida State needs to take that first ever African-American degree back if I missed that one. But of course the climate changes naturally. Here's an example of that. I mean, this is the last 800,000 years. Here is something called the Milankovitch cycle. So we've got glacial and interglacial periods. These are caused by changes in the orbital mechanics of our planet, changes in the orbit around the sun, slight tilt changes, little wobbles and precessions. That's natural change, right? But after 1850 or so, we see that we've gotten outside of the natural bounds. So during these glacial periods, to get back to your question, sir, this is when we would see extensions of polar ice deeper into the continental regions. So because of these Milankovitch and other natural processes, you do get an ebb and flow of the polar ice caps, right? Milankovitch cycles. Yes. Yeah, it's not just solar. I mean, it's several factors involved in that change in net radiation to the system. What I would posit, though, is that, and I get this question like, well, it's the sun, or it's all these things. But this would be a completely different. I have a different talk that I give on Climate 101, and I talk about the greenhouse effect and the net importance of the radiative gases, the greenhouse gases in our system. How many of you like quiche? Really, that many people? Oh. But what is the primary ingredient in quiche? Right, eggs, right? So someone coming up to me and saying volcanoes or the sun are the reason we see changes in our climate is like saying the green peppers are the most important ingredient in quiche. It's the greenhouse gases, the radiative forcing, that is the greenhouse version of eggs. That resonates with you. And so to understand this notion of how the Milankovitch cycles affect change, one of the things that you'll see in sort of addressing your question is there was a natural, this is not the graphic, this is in my other talk, but I have a graphic in here that shows the resultant temperature changes in response to the Milankovitch cycles, and there was an inherent limit that was never surpassed. But after 1850, we add to that, and this is the point I want to make with this last slide, because grass grows naturally, but if I put fertilizer on it, doesn't it grow differently? I've altered the natural cycle. So the point I'm making that really I try to get across to people, it's not either or, it's and. Yes, there's natural variability in our climate system. Of course there is. But there is an anthropogenic contribution also contributing. I don't know why that's so hard, but it is. People want it to be, no, it's just natural variability. And yeah, we had hurricanes 1 million years ago probably, or 500,000 years ago. But it's an and problem, it's not an either or problem. How did OJ get in this talk? Perception of uncertainty, right? This is another one of those sort of issues as it relates to sort of the Dunning-Kruger I often see. Well, you can't trust the climate models, they have uncertainty in them. Well, you guys don't really know what's going to happen with the aerosols or the clouds. Those are true scientific statements, by the way. Those are areas where there's uncertainty in their influence on the climate models. And I think, I'm not sure if I'm right about this, but it's a hypothesis that I have. I think the O.J. Simpson trial made people very aware of the concept of reasonable doubt, which is if you can establish in a legal case a reasonable doubt, you can get the person off. I think a lot of people now believe science works that way. If there's a sliver of uncertainty, it's all not true. And that's not how science works. If there's an 80% chance of rain, there's a little uncertainty in that, but I bet most of you grab an umbrella. So that doesn't necessarily mean because there's uncertainty in science, it's not usable information there also. Okay, from the Dunning-Kruger effect, we go to confirmation bias. And this is very important again when we talk about climate change, because people consume information that aligns with their own core beliefs or perspectives. That's called confirmation bias. We're all somewhat guilty of that to some degree. But when it comes to climate change, because climate change is painted as if you're for or believe in climate change, you're liberal, and if you don't, you're a good conservative. But yet, look at these two conservatives and what they say. I had Bob Inglis on Weather Geeks talking about this. Look at Hank Paulson, President Bush's Treasury Secretary. Climate change is a challenge of our time. Each of us must recognize the risks are personal. We've seen and felt the cost of underestimating the financial bubble. Let's not ignore the climate bubble. That's a conservative. Bob Inglis, on the Weather Geek show, he started rattling off all his conservative ratings. I've got an A+ from this, an A+. He's conservative, I got it. But look what he said. Aspects of the science are not settled. There are always some uncertainty in the science, but it certainly indicates risk. It is against conservative principles to ignore risk. That's a fundamental tenet if you go back and look at conservative principles. So what I'm trying to illustrate here, there's that even core confirmation biases that people have in terms of how climate change is supposed to align with their political ideology is flawed. Challenge 4. Too many graphs, too much jargon, not enough common ground. I'm about to go down the road of my colleagues here for a second. Here are 3 different presentations of sea level change. That's the causeway from Savannah, Georgia out to Tybee Island a couple of years ago. It's completely underwater from a king tide flood. It wasn't a storm. This is satellite data showing changes in sea level, and this is an EPA graphic of vulnerability to sea level rise along our coast. My point here is that depending on what audience I'm talking to, and I wanted to convey a message about sea level rise, I might show this if I were talking to the Rotary Club. I might show this at a conference, and I might show this if I'm talking to a group of planners in a coastal town. The message cannot be the same when we're conveying science information. The message has to be tailored. We have to get beyond using jargon. This is from a very good paper by Somerville and Orville So for example, positive trend. In science, we know that a positive trend means it's going up if we were to plot the data. But doesn't the word positive sound good? Positive trend in CO, good. PDF, probability density function. If I say PDF to my wife, she thinks I'm talking about an attachment in a file format. Uncertainty. Oh, they don't know. They're uncertain. That's not what uncertainty means in science. But to the broader public, uncertainty means we don't know. So we have to be cognizant of those types of sort of jargony things that we as scientists take for granted but throw around very casually in the public sphere. And we are all training our graduate students in the wrong way for communicating to the public. Me included. Because my graduate students, when they write their dissertations or their theses or they give a paper, they start by giving background information, supporting details and results and conclusions. That's the recipe. You've got to do it exactly the opposite when you're talking to a congressman or to a governor or to a CEO of a Fortune 500 company. The bottom line up front, the so what, and then the supporting details. And I was talking to some students today over at the university, and they were asking, I think it was in John Martin's class, asking, do we need sort of these types of things taught? Given the backdrop of the science battle we're in right now, I absolutely think this needs to be integrated more into science training of our students. Because Scott Pruitt, yeah, okay, bad. I don't have any Tums for you, sorry. Politician A is not going to read the Journal of Applied Meteorology. They're not going to the American Geophysical Union. That is why I write a column for Forbes or do the Weather Geeks. Hi, you're University of Georgia. Yeah, I just noticed you. And you're up here now? Oh, cool, that's right, I did, for my department. So this is from the American Association for Advancement of Science. I hosted a workshop on communicating science in Atlanta with my colleague Kim Cobb a few years ago at Georgia Tech. This is a very fundamental thing that we have to get folks to remember. And then we have to find common ground. I was talking to a very conservative congressman in my state staffer, and it was back during the drought in California. He was like, Dr. Shepard, why do Georgians care about drought in California? I mean, you guys keep hammering drought in California. Why do the people in Georgia care about that? And I was like, well, are they going to eat a salad tonight? Are they going to go to Subway and let the Subway artists or sandwich artists make a sandwich for them? Because something probably in that salad or on that sandwich was grown in California. Here's a look at all of those things. Almonds, 99%. 90% of tomatoes, 70+% of lettuce. We like wine, right? Grapes. So these are the connecting points to the value systems in Georgia of why they care about drought in California. So we have to find those core values when we're communicating. We've got 2 more challenges. Challenge 5, general climate literacy. We have to increase it. I can't tell you how many times after a snowstorm I'll get someone say this to me. Hey, Dr. Shepard, I got 20 inches of global warming in my yard. It's cute, it's funny, I actually do laugh. But it's really scientifically inaccurate statement that shows that the person doesn't understand the difference between weather and climate. Because weather, as I like to say, and actually I think I got this from John Knox, one of my colleagues, weather is your mood and climate is your personality, right? That's a good way to help you distinguish the two. A given snowstorm or even a week of snow says nothing about climate change no more than a given hot day affirms climate change. But yet people fall into that trap all of the time. Sports, we already had sports. OJ was a football player before he was OJ, right? I think this is a Wisconsin coach. Look at that playbook or play sheet he's holding. Got all the realization of football plays that can happen on the next play. He's climate. Oops. But what this player decides to do in the next play is weather. I got a million of those, by the way. Weather is what you have on, climate is what's in your closet. Lots of them. But the point is, people don't, in some cases, understand the differences, and then they sort of conflate the two, and we have kind of moved beyond that. The other problem in the climate literacy is the whole causation problem. We're seeing that a lot with Hurricane Harvey, Hurricane Irma, and the current generation of extreme weather events. Well, was that caused by climate change? That's a flawed question. We have to move beyond asking, was it caused by climate change? That's an ill-posed question, but the media asks that to me all the time. Better questions center around, is that event becoming more frequent or intense as a result of climate change? And believe it or not, there is a new subdiscipline of our field called attribution studies, where scientists can now do attribution to see how much of a current event may be linked to climate change. And so that's why when a reporter contacts me about Hurricane Harvey and says, was that linked to climate change or was that caused? I said, I want to wait for the attribution studies to happen in the next few months. I said, my gut feeling says, yeah, there probably is some connectivity in some way, but I think it's premature. And if we're too speculative on these types of things, it hurts our credibility for really trying to communicate the threat of climate change. That's just the world according to me on that. But more sports. That guy is dunking a basketball, right? How many people in this room legitimately, and not because you're trying to impress the friend sitting next to you, can dunk a basketball? Well, at least one person. I could back in the glory days, 20 years younger. But what if I added about 5 feet to the floor? Then we all probably could, or most of us could. Remember that it's not an either or, it's an and, because we're adding to the floor. And that's how you have to consider this notion of attribution of extreme events, right? I'll give you another example using baseball, one I use often. There was an era of steroid use in Major League Baseball. And some of the people that we know very well had very inflated home run numbers. Now, some of those players could hit home runs whether they took steroids or not. So I can't say, for example, that player X's 269th home run was caused by him using steroids. But I can look at his overall statistics and clearly see the influence of steroid use. And this is how we have to think about extreme events within the context of climate. And then finally, the climate, we've seen the weather zombie theories. The ones that I get the most are the climate zombie theories. Here they are. Climate's changed before. It's the sun. It's not bad. There's no consensus. It's cooling. Models are unreliable. Temperature record is unreliable. Animals and plants can adapt. Hasn't warmed since 1998. Antarctica's gaining ice. So what are you guys talking about? And there are many more. You can go to this website here if you want to see them. That's a very good website for refuting many of the climate zombie theories. And oh, by the way, scientists just want grant money. That's what they talk about all the time. I don't know any scientists that got into this to get rich. I don't know any scientists with gated communities, yachts, and things like that. I've never really understood that one, but it's a zombie theory. So as I draw to a close, I think as scientists we have to be careful. Anyone that really knows me knows that I try to be measured, I try to be objective. I'll tell it like it is too, but I try to be very measured and objective. But I do argue that we need to be a bit more forthright about the risk. I think, and this is one of the things that the skeptic community has sort of tried to paint us as alarmists. When in fact, I think climate scientists have generally been conservative to our detriment, because we do worry about our reputation as scientists. We do worry about the appearance of objectivity. But there are some things that probably need to have the alarm sounded a little bit more than we do. And so I've decided that that's the road I'm taking, within the context of the peer-reviewed science, not hype and alarmism. So for example, here's Arctic sea ice extent, the 2016 average. These were sort of the averages over the 81 to 2010 period. The point here is that some of the things that we're seeing that are happening are beyond what we expected. I don't think we tell that story as vigorously as we probably should or could. And at the end of the day, I'm going to sort of peddle my kids for a second. Shameless peddling. But no, I'm serious about this, because I'll have a climate skeptic come up to me and say, you guys are wrong about this. You're hyping this up. This is a hoax. This is unbelievable. You want grant money. It's a hoax. You're wrong. And I look them dead in the eye and say, sir or ma'am, I pray that you are right and I'm wrong. Because if I'm right, they lose. If I'm right, they suffer. I have no vested interest in winning this. So that's really how I try to leave the discussion, because I think that most scientists are very much in this for the good of the science, for interest and understanding, not to win. Thank you very much. Thank you. So I think at this point, do we have a time for a few questions, John? Yeah. Okay, I'll take a few questions, sure.
Yes, a lot of citizen scientists are out there doing weather spotting.
Absolutely.
All that. Are those trends getting better and more people getting involved, or maybe people are getting about all of that?
You know, I think there is growth in citizen science. I'm a CocoRoz observer myself. If you want to take measurements of rainfall, go to the CocoRoz website. You can order a $20 rain gauge and start taking rain measurements and entering them. You have all kinds of other, thank you. You have all kinds of other, the MPing, or is it MPing or ping? I can't remember exactly what it's called these days. So I actually do sense that it's growing. I was just even looking at the eclipse recently and all the citizen science related activities there. Could we have more? Absolutely. The big challenge with citizen science, however, I think we need a level of consistency in the quality of the data in terms of consistency in collection, quality control. Otherwise, a skeptic said, well, I don't know, I don't believe that, because that measurement's taken at 7 o'clock, but her measurement's taken at 6. So there are some standards that we need to, as we start seeing more citizen science, hopefully some of those standards are being met. And I think projects like GLOBE and CocoRoz and others try to institute some of those standards. So.
I've got a mic, I'll bring that around, and then I'll get another one over too, so I'll go back here first.
So there's a known psychological effect called the backfire effect, where when someone's beliefs are threatened, they will double down instead of reasoning to reason. Yeah. What would be your tips to counteract that?
Well, in many cases, that backfire effect, and there's a related phenomenon called cognitive dissonance as well. And this whole notion of cognitive dissonance, or at least a part of it, is that the challenge is some people are very smart and attentive to science issues, so because of that, they can actually make very credible arguments that are dead wrong, but they can still make them sound very credible. But what I tend to find is that people that kind of recoil, the backfire effect, fall into that 13% dismissive, 10 to 13% dismissive category anyhow. And so if I detect that, there's a colleague of mine who's I consider a mentor named Admiral David Titley at Penn State University. He says at that point you just say thank you and move on. And so that's my own personal approach. It might not be the right approach, but at some point you've heard the term, you got to cut your losses. You have to cut your losses with some people.
Yeah.
Oh, okay.
What if those people are powerful decision makers? I'm thinking of some members of the Senate, for example.
I'm thinking of a lot of other people that come to mind, actually. That's a hard question because, I do interface quite a bit with the political arena, but I always try to remain a scientist. So I'm happy to go brief Congress or the White House. I briefed the White House a lot in the last administration. I don't expect too many invitations this time around. But it's important to open yourself to anyone, no matter. I think if they're willing to learn, and hear you, I think you have to take advantage of the opportunity. I'll give you an example. President Trump just nominated the new administrator of NASA, Congressman Jim Bridenstine of Oklahoma. Now, immediately, everyone's knee-jerk reaction is, oh my gosh, he's a climate skeptic. He's going to kill the NASA Earth Sciences program. But I actually happen to have some insight and interactions with this particular gentleman. So I wrote a Forbes article, sort of like, who's the new NASA administrator? Who is he, Jim Bridenstine? And I was trying to sort of lay out an argument that in this particular case, there may be an opportunity with this person because he's not an ideologue like some people are that you may be thinking of. There are some people who are just ideologues and you're not going to reach them. But I think from my own interactions with him in other arenas of our field, he's more pragmatic. And so if you can lay out an argument or you can lay out the information in a way that sort of understands and hears his value system or her value system, and this kind of gets back to what I was talking about, you don't go in with an adversarial, confrontational perspective with people. Meet them where they are. And if you can, you might be able to make headway. But again, there are some, I mean, we just have to face the fact there are some politicians, some people that you're not going to reach. The only way you're going to reach them sometimes is if there, is a bottom line impact on them personally or their finances or their core belief system. So once you can sort of develop that litmus test to know who really is reachable, who's in that, that Six America is in that middle to slightly to the right of the middle category, those are the people you target.
This kind of goes to some of what you just mentioned, but it seems like in the current debate about science, and the political climate, we have this false dichotomy between two really powerful meaning-making systems, one being religion and one being science. Like, how do we understand our world? And the category of like, these people are smart, these people aren't. And I would argue in this audience, you have a lot of people that are very vested for legitimate reasons in having credentials. And I think that when we go to those false dichotomies, how do you see making the bridge? Because I think that there's more in common in the process of meaning making than there is separate.
I agree.
And so in your position, like, I applaud you for trying to make that bridge, because I think it's a fundamental step in coming up with the answers and the problem solving process. But a lot of the rhetoric is really contentious, and again, I would argue a false dichotomy. So can you talk a little bit about those, how you see that bridge and how you talk to people who have start with very clear points of difference in their meaning making?
And again, it comes back to a couple of thoughts on that. One, it comes back again to values. You find the common value. So, I am of faith, so I actually have an entire climate talk that's faith-based, for example. And so when I go into certain faith-based communities, the bridge is, stewardship of the earth. And I start there and work from that common value and then work out. When I speak to what I know to be fairly conservative groups, I don't hit them over the head with trend lines and it's warming and all that stuff. I talk about core national security, economic issues, and then circle back to these things. And I might not in that talk ever mention the words climate change. So, it's one of the things that I find that people sometimes struggle with. They want to use the same message to every audience, and they want to essentially, quote unquote, beat someone into submission to their belief system. That doesn't work. But if you can find at least those common threads of as you say, because I do believe there's more that binds us than divides us. If you can find at least those threads and then build relationships, there's a person that's a well-known climate skeptic in our field that I actually am publishing a peer-reviewed paper with right now. We violently disagree on some aspects of the climate science, but on this piece of science, we could work together. And because of that, we built a relationship. And so now, even in public discourses or in social media or wherever, we will stand up for each other. We will demonstrate that we're human beings first. And if we can, I guess one thing that comes to mind is if we can sort of default back to being humans first instead of our ideologies and positions, we can make make up some ground. That I really believe that. I mean, that's my approach in a lot of things, right?
Yeah, I'm a meteorologist from Northern California along the coast. People along in my rural area are preparing for climate change by getting off the grid with solar electric panels.
Sure, yeah.
And learning to save their rain and to grow their own food. I just wondered what you and your family in the southeast part of the United States are doing similarly. Are you preparing for climate change?
We are. We've made some very specific decisions about the types of cars that we drive, for example, and the types of things that we have put on our homes for energy generation. I'm leading an effort in the state of Georgia. One of the leaders is called the Georgia Climate Project, and it's a consortium of academic stakeholders and businesses. They're trying to develop solutions for the specific problems that Georgia's facing. You can go to Georgia Climate Project website to find out some of the things we're doing as it relates to sort of the top 50 science questions facing Georgia, climate questions facing Georgia. We've laid those out. We're developing a series of climate stories, because one of the things that I'm also a big proponent of is we've got to move away from showing graphs, charts, and maps. We've got to tell stories. People resonate with stories. And so, that's one of the things that we're developing to try to convey the message in story format, because I think that's what we need to reach people that we currently aren't reaching. So, quite a few things that were going on. I don't have time to kind of go through all of them, but I would say yes, I'm vested.
Hello, Dr. Shepard. Thank you for the great talk. So to continue your last words, what do you think are the most efficient ways to educate the general public in science?
Oh boy, if I knew. It's a tough question. I think stories are one of them. I think distilling the information in a very accessible, non-jargony way. I think, again, one thing that you probably saw me try to do at times is bring it out of the realm of what people perceive climate change to be about, and bring it out of the realm of polar bears and butterflies to kitchen table issues. Everyone has a child or a grandchild that doesn't want their child to face a new form of disease that now can thrive because that mosquito can now live in that climate. I mean, that's a kitchen table issue. That's a public health issue, right? But people most people, not this audience, but generally people don't make those connections, that there are kitchen table issues facing them now and going forward. So I think that we have to be very clear to find the connectivity to people's kitchen table issues and where they are. I think that's very important, actually. Maybe one or two more questions. I heard an Oh, there you are.
What do you think the role of both K through 12 education and higher education is?
And the child shall lead them, if you know that quote. I think it's very important, because one of the things some studies have shown is that beyond a certain age, people are sort of molded in their belief system. They're not changing, right? But I have found in my own research and in looking at sort of my own interactions with people that children, that's one of the things that gives me hope. Because children, and even to some degree collegiate age kids, kind of get it for the most part. That's what kind of keeps me going when I hear certain things that really get me down. I'll think about that I was just in that classroom where probably most of those kids' parents have a different view, but yet the kids were asking the right questions. So I think that, and just to sort of as an aside, in our field in general, I was president of the American Meteorological Society, and we did a survey of our membership one year while I was president. And we find that the majority of people that go into our field or do what we do got stimulated in middle school or late elementary school. That was my story. And so I think it's vital, and that's why I'm so worried about some of the things that I've seen with certain organizations sending false climate reports and false books into the schools and sending them to teachers. Did y'all know about some of this that was happening? An organization was actually sending out the non-governmental climate change report or something. They sent hundreds of thousands of these to schools all around the nation and the teachers. And to a teacher that doesn't know the difference, it looks very official, but it was non-vetted, in some cases non-peer-reviewed science. So the fact that that's happening tells you that some people that have an agenda realize the importance of K through 12 also, because they're trying to pollute the message. That's why it's important to keep an eye on what's going on with curriculum development in states and local jurisdictions, and make sure that proper science is being taught and not these alternative theories. That's happening. So that's where we all can get in the battle, by going and understanding and making sure we know what's in our current science curriculum. I can hear you. I'll repeat it. No.
As you know, most of Europe is north of where we are. Chicago,
Sure.
New York. So if you're going south, for us going north, we're a warm area because of the Gulf. Not to worry about the saltiness of the Gulf Stream as it moves. Iceland and back.
Yeah, the thermohaline circulation, sure.
And pumping the whole
Mm-hmm.
the world. And melting Greenland or areas around fresh water dumping into the warm and turn them.
Yeah, I think that we have.
People have an estimate.
Yeah, I think you got to be careful. No, I think you got to be careful.
There's some worries about that, and there's even some evidence that some of that is being.
Yeah, I think you got to be careful though, because I think that kind of statement actually is a little over the top, and then it does hurt our credibility, because it's not going to shut it down. I don't think there's really any evidence of that. There is some concern about disruption of for those that don't know what he's talking about, there's something called the thermohaline circulation, or the ocean conveyor belt circulation. If you saw the movie The Day After Tomorrow, that was the whole premise of the movie, is that it did stop, and so weather went crazy. It's a bit exaggerated, but yes, there is some evidence. If you look at warming maps, you always see this persistent cool spot up there in that same region you're talking about. This is something that many of the climate models kind of sort of sniffed out or predicted decades ago. NASA launched an entire satellite called Aquarius a few years ago that measures nothing but ocean salinity, how salty the ocean is. Well, people are like, well, why would you do that? Because it is vital to understand the sort of balances between fresh and salt water in the ocean, because that does drive density differences in currents and those types of things. But again, I am very cautious about statements that we're going to shut down the thermohaline circulation, or that Greenland's going to melt and sea level is going to rise 20 feet, because I think such alarmism does as much harm to us as flat out denial. And so I would caution all of us as we're making these arguments we don't need to go to the most extreme case to make our point, right? If we stay within the boundaries of credibility, I think you then don't give the skeptic crowd the ammunition it needs to say, see, they're just being alarmists. So maybe one
more question.
I'll take one from Scott, since I know him.
John said you got into meteorology because of a bee, and I'm kind of curious about the whole story.
You'd remember that.
Oh, yeah, I guess I can tell that story. So, as a curious kid, I was always into science, and so as a fifth grader going into sixth grade, I was always couldn't wait to do my first science project. It was sixth grade in the hometown I started. So I'm out catching honeybees in my yard, and so I used to catch the honeybees and put them in mason jars and poke little holes in them and put little clover in them. I don't know, I just thought that was fascinating. I got stung by one and almost died, and I found that I was highly allergic to bee stings. I almost suffocated from what happened. So now I'm supposed to carry an EpiPen. I'll tell my wife that I don't, but. So I was stung by a bee, and I was like, well, I can't. I was going to do my science project on honeybees, and I said, well, I better not do a science project that can kill me. So I decided to switch to weather, and so I did a science project called Can a Sixth Grader Predict the Weather? And I made weather instruments out of things around the house, developed a little weather model for my community, and the rest was history. I mean, literally, I was bitten by the weather bug, pun intended. And so at that point on, Scott, I started looking around. I was from Georgia, so what meteorology programs are in the South? I want to be a meteorologist, but I don't want to stand there and say, tomorrow's weather. I didn't want to do that. I didn't want to be, quiet as kept, I'm not even really interested in day-to-day weather forecasting. I was always more kind of on the how and why. My degrees in was physical meteorology at Florida State, so really kind of the physical aspects of what's going on in the atmosphere and radiative transfer and cloud microphysics and those types of things. So Florida State, I found, was 4 hours from Atlanta, had a really good meteorology program, and the rest is history. So for anyone that knows a fifth grader or a seventh grader that says they want to do something, don't doubt them. My daughter right now is in eighth grade actually, and she says she wants to be a parasitologist. And by the way, Wisconsin is one of the schools on her list because she found out that they have a really good parasitology program. At 12, she researched this. Parasitologists, infectious disease animals, that kind of stuff. So I'm not one that would say, no, you're not going to do that. You're going to change your mind, because I know my own story. So thank you guys so much for coming out. Thank you.
Thank you very much, Marshall.